detail of which will be covered by Dr. Sanjay in the later session. But for now, I will say that there are some attacks which can change the DNS response that is reaching to you. So there may be cache poisoning attack, there may be corruption of data, there may be impersonation. So there are so many kind of attack. So the question is, how can we authenticate that the data has originated from an authoritative server? And how can we ensure that the data is unaltered, or basically the integrity of the data or the DNS response is maintained? Nothing has been changed. So for that, we require DNSSEC. So we'll see how DNSSEC works. So DNSSEC basically adds cryptographic signature to existing DNS record. So whatever DNS records are there, a corresponding signature will be added for all the DNS record. And whenever somebody queries to the DNS server, first the signature will be verified. And if the signature is verified correctly, then only the response will come to the user. Now, so this ensures that there is no modification on the root, as well as there is no fake record injection. So, so before I start talking about DNSSEC, there is one thing, cryptographic signature. So I will take a brief time on explaining how this cryptographic signature works, or if you tell me that you all are already aware with this cryptographic signature, then I will skip. Okay, so no response, so I will continue. So we all sign a paper with handwriting. However, in the digital world, any scan copy can be copied and pasted. So there is a cryptographic mechanism to add a signature on a document. Now, to add a signature on the document, each user or each entity are given two keys. One is the private key, another one is the public key. So this is called public key cryptography. Now, if I want to sign an electronic document, I will use my private key, because the private key is only available to me. Nobody else can see that private key. However, for verification of the digital signature, anyone can use my public key and verify it. And it is intuitive because the public key is available to everybody. Basically, anyone can see my public key and verify my digital signature. So I will just go through the process of digital signature. So consider this is the message that has to be sent to some other person. So I want to add a digital signature to this message. So for that, there is a first step that I have to create a hash of the message. So what does hash do is, so hash basically gives a digital representation of the message, which is of a particular length, a fixed length. For example, MD5 is for 128, SHA1 is for 160 bit, and similarly, there are other 384 or 224. So there are different output length of the crypto hash. So once we hash the message, we get a message digest, or it is also called the digital fingerprint of the message. Now this message digest, we have to encrypt using the private key. Whatever output is there after the encryption with the private key, that is called digital signature. Once the digital signature has been generated, it is simply appended to the message. Like we write signature at the end of the paper where the content is there. Similarly, this digital signature will also be added to the content, basically the message, and it can be sent to anyone. This document is digitally signed and it can be shared with anyone. Now in the verification part, it's just reverse. So I have already a message and I have a digital signature. So on the message, I will apply the crypto hash and I will get one message digest. And also the digital signature I will decrypt with the public key and I will get another message digest. So you can see here in the last, how was digital signature created? So it was created by encrypting the message digest. So it means that if I decrypt this digital signature, I will get back the message digest. So same thing here. So I have to decrypt this digital signature. So I will get a message digest, and independently, I also have the message. So I will apply hash on the message and both will be message digest. I just have to compare whether both the message digest are same or not. If they are same, it means my signature is verified. If there is any change, suppose even there is a space has been added in the message, then the hash will be completely different and the message digest won't match, and we will say that since the message has been altered, so therefore digital signature could not be verified. Is this fine? Are you able to hear me?
Yes, you are audible.
Okay, thank you. Now, so DNSSEC also does the same thing. So there are resource records. Maybe in the last presentation you will have seen there are A record, AA, MX record. So there are multiple resource records. We just have to add signature. So we'll see that after introduction of the DNSSEC, what new resource records have come. So first one is RRSIG, which is resource record signature. So it contains a cryptographic signature corresponding to one resource record. Now, second one is dnskey, which contains public signing key, because as I said that for digital signature, you require public key and private key. Now, private is stored safely, privately. It is not visible to anybody, but the public key that is contained within a dnskey resource record. Second one, the third record is DS, which is called delegation signer. So delegation signer is used for propagation of trust. So how that will be done, we'll see later. Next is next secure record and next secured record 3, NSEC and NSEC 3. So suppose that I query a web server, query a DNS server, and there is no record for that. Maybe the domain is non-existent. Now I cannot sign a non-existent record, which is not there. So what does NSEC does is it gives the next secure next record, which is in alphabetical order. For example, suppose that on a server there are records like auth and mail. Okay, so auth and mail.cdac.in, auth.cdac.in, mail.cdac.in. But I deliberately asked about drive.cdac.in. Now drive.cdac.in is not there. So what it will do is after D, whatever alphabetical order next subdomain is there, which in this case is mail, will be returned as the next secure record. So this is for explicit denial of existence. And last is C-DNS-key and C-DS, which is basically child DNS key and child delegation signer. It is used for automatic delegation or automatic routing of the DS record to the parent. Why it is required, we will see later. So these are the new resource record. Now let us talk about what is RR set. Okay, so next question, one question is that please explain NSEC again. So whenever we ask for a record, if it is not there, it will give me a blank, like this domain does not exist. Now since we are using DNSSEC, every record has to be signed, but I cannot sign something which is not there. So therefore, what it does, it gives, whenever a domain does not exist, then it returns the next domain in the alphabetical order, which is present in the that zone file. So for example, if I ask for drive.cdac.in, it is not there. So whatever next in the alphabetical order is there, suppose mail.cdac.in is there. So that record it will sign and send it to me. So that is for denial of existence of a DNS record. Now next is RR set. So RR set is basically all the records with the same type on the same label. So what does it mean? So it means that suppose you would have seen that many websites, they have multiple A records. So for example, you can look for Microsoft.com. So it will have multiple A record, multiple IPv6, basically the AA record. So all the multiple records, they are in one single RR set, which is resource record set. So for example, if for Microsoft, there are 4 A record and 2 AA record. So the first 4A will make one resource record set, and another 2 for the AA will make another resource record set. So you can see this example in which there are 3 A record and there are 4 MX record, which is basically the mail exchange record. So they make one RR set for the A record and one RR set for the MX record. So this is resource record set. Now, when we do a DNSSEC signing, so all the full RR set is signed. So individual A records are not signed. All the A records corresponding to one domain are signed together. One domain, I mean to say the one label, for example, www.microsoft.com. And even the verification of the signature will happen on the entire RR set. So this is important, that the DNSSEC signature is applied on one resource record set, not an individual A record or AA record. Okay. So next part is that now we need to sign the records. So we need some keys, like I was talking that we need some public key, private key. So similarly, here there is this key set is called zone signing key. The zone signing key is basically used for signing a RR set. Okay. So they will be in pair, private key and public key. So private key will be used to sign the RR set and public key will be used to verify the signature. So suppose there is a RR set for AA for www.google.com. So the private key will be used and the resource record which will come will be RRSIG, which is a resource record signature. Now for verification part, what will happen is that there is a DNS resolver which will basically query the zone. It will get a RR set. It will also get a signature on the RR set. And finally, we need the public key for verifying the signature. So these 3 things should be there so that I can finally verify that whether the signature on the RR set is genuine or not, verified or not, valid or not. Okay. So earlier message also we had seen that we need the original message, we need the message digest, and we need the public key. Using the combination of all these 3, we can verify whether the signature on the message is valid or not. So same thing here also. We have a RR set, we have a RRSIG, which is the signature on that record, and we have a public ZSK, zone signing key. We will use all the 3 to validate whether the RR set is the signature on the RR set is valid or not. And if signature is valid, it means that the RR set is also valid. Now, the thing is that zone signing key, we can use it to validate all the records. But what if the zone signing key itself is compromised? Somehow it is known to other. Now, as an added layer of security, as an added layer of security, in DNSSEC, we have another signing key, which is called key signing key. So what does it do? So key signing key basically signs the DNS key. Okay. So it will basically create a resource record signature for DNS key. So how does it work? That zone signing key will sign the zone, and then that whatever DNS key is there for the zone signing key, that will be signed by the key signing key. So you can see here in the example that public zone signing key is there and public key signing key is there. So both will be considered as one RR set, because I had already told that for the same label, like for A record, all the A record will be treated as one RR set. So similarly here also, all the DNS key will be treated as a one RR set, and then that RR set will be signed using the private KSK. So after signing, because only private key is used for signing, so after signing, it will become a RR signature, RR sig on the DNS key. So basically for DNSSEC, we require two set of key. One key is zone signing key, which will sign the zone. And then we have key signing key, which will basically sign the DNS key, the zone signing key itself. Now we'll see the full picture of the record verification. So I have a RR set, then I have a RR signature on the MX record set, and I have a DNS key, which is the public zone signing key. Now, if I use all these three keys, then my RR set will be verified. Fine. But the zone signing key, that itself has been signed by the key signing key. So we need to first verify the zone signing key. So for that, we need the DNS key set. Then we need the signature on that DNS key. And we also need the public key signing key. These three things. So if these three things are there, then the public ZSK will be verified. So these three things will basically verify whether my zone signing key is valid or not. And once my zone signing key is verified, then using this MX record RR set, RR sig, and the verified public zone signing key, I can validate the RR set itself. So two level of verification is there, that since my records have been signed by zone signing key, so first I should verify the zone signing key. And once the zone signing key has been verified, then I will verify the resource record. So two level validation. But remember, this is only within a zone. But in DNS, there is a hierarchy. So hierarchy means I am suppose C-DAC.in. So I am the name server for C-DAC.in. Above me, there is a .in, and above .in, there is a root server. So whatever signature I did, it was only valid for me in my zone. But how will the my parent will know, or how will the trust be propagated from me to my parent .in to the root server? So for that propagation, the next concept is delegation signer record, which is called DS record. So this delegation signer record is basically we create a hash of the DNS key containing public key signing key, and then give it to our parent zone that this is my key, you take it, and whenever somebody comes for verification, you verify that yes, this is my key. So how does it work? So there is a child zone. So child zone will take its own DNS key, which will be public KSK, hash it, and after hashing it becomes a DS record, hashed KSK, which will be inserted into the parent zone record. So after I complete the signature on my own records, then I have to create a DS record, and that DS record I have to send it to my parent zone, so that the trust will propagate to my parent .in. Similarly, .in will also create a signature for its zone, and after that it will also create a DS record, and that DS record it will send it to its own parent, which is the root server, root DNS server. So this is how the propagation goes. So I sign, I create a DS record, I give it to my parent. Parent signs, creates a DS record, gives to its own parent, which is the root server. Now, how can I verify the DS record? So for that, from the parent, I will get the DS record, which is basically the hashed KSK. And from the child zone, I will get the DNS key record. On the DNS key record, I will apply hash. That will also give me a hashed KSK. So if these both are same, if this both hashed KSK are same, it means that the trust from the child has propagated to the parent. So let's see the chain of trust. So there is C-DAC.in zone, and it has a public KSK, which it will give it to its .in zone. .in zone will have its own public KSK, which it will give it to root zone. And for root zone, there is a private root signing ceremony. So in which many individuals across the world, they come together and in a transparent manner, they sign the root zone. So for that, I do not require another DS record. So this is how the chain of trust is maintained via a DS record, which is basically hash of key signing key. So now we'll see the full verification process. So root is there and a client is there. So client will ask for www.cdac.in. So root will return multiple things. One is the RR set, another one is RR set signature, and then the DS record for in, and the DS signature, and the referral for .in. That this is the name server for .in. So the client will verify the RR set signature by decryption using key signing key. It will also verify the DS signature using zone signing key. And once it has got the DS signature for .in zone, it will connect to .in. .in will return it again the same set of values: RR set signature, DS record, DS signature, and referral for the next domain, C-DAC.in. Again, the verification will be done, and after verification is completed, now it will connect to C-DAC.in name server. It goes to C-DAC.in. C-DAC.in will return RR set signature, A record, and signature of A record. And since we only require the www.cdac.in, it doesn't need to give further DS record for its child. It has no child ultimately, so it will not give a DS record. So this set will go to the client. Client will verify the signature on the RR set, and this time only comparison of the DS record obtained from the parent and obtained from the zone itself, that will be done, and DS will be verified. And ultimately, once the signature on the record, A record, is decrypted and compared, then the RR set, whatever A record in the RR set is there, that will be given to the client, final client. So this is how from top to bottom. Earlier we saw the example from bottom to top, where the public key signing key was added as a DS record in the parent. Now this time we started from the root, just like the DNS query works. So NSEC record, we have already discussed that if any non-existent domain is there, so there will be empty answer, then what should we sign? So for that, there is NSEC record, which is next secure record. So it gives the next domain which is there in the alphabetical order. So for example, here I have written A record for auth, drive, mail, and www are there. And suppose somebody requests for A record for SMTP. Now SMTP is not there. but it falls just before the www. So NSEC record containing www will be returned. In that way, the signature on the record can be verified. But there is a problem. So what is the problem is that it is prone to zone walking. Zone walking means I will give, so whenever I am asking about a non-existent record, it is giving me the next genuine record. So in that way, I will keep asking some or the other record, and it will give me all the subdomains which is there in that particular zone. So for example, I will ask about one dot, suppose one.cdac.in. Now O is not there. So next will be www, it will return. Similarly, I can ask about, suppose email.cdac.in, and email.cdac.in is not there. So it will return me after em is there. So mail.cdac.in. And in that way, I can get all the subdomains that are available in that website. Now somebody will ask that, okay, so what is the big deal? So many times it happens that some of the subdomains that are internal for the organization. For example, for C-DAC, we have ihrms.cdac.in, or maybe some authorization.cdac.in. So which is only for our internal consumption. It should not be publicly announced. So for that, avoiding that zone walking, we have NSEC 3 records, which basically cryptographically hashes the record. So if the record is hashed, then it is difficult to enumerate the next record in the zone. So NSEC 3 is mostly used now, but still you can use NSEC also. It is up to the system administrator. Okay, so let's summarize it. So DNSSEC basically guarantees the authenticity of DNS answer origin because it is signed by the authoritative DNS server. So we can assume that whatever response is coming, it is genuine, it is authentic. It also ensures integrity because we have seen that it uses a hash and we compare hash. So if any small change also is there, so hash will not match. So in that case, we will say that, okay, this and response has been altered. So integrity of the reply is there, and there is authenticity of denial of existence, which is done using the NSEC record. Now, one important part is that DNSSEC doesn't provide confidentiality. So whatever response we are getting, it is signed, not encrypted. Remember. So if something is encrypted, then only it provides confidentiality or privacy. But if it is not signed, so it will only give us authentication and integrity of the response. And of course, it cannot protect against denial of data. So any denial of data attack is there, so that DNSSEC cannot cover. It's simply authentication and integrity. So implementation we will see at the last. So now we'll go to next topic, which is DNS over HTTPS. So any question till now? Okay, so okay, so next, since there is no question, so we'll move ahead. So whenever you are doing a DNS query, so from client to DNS resolver, the query goes in plain text as a UDP packet. And whatever response comes, that is also in plain text. So anyone who is there, because since all the packets go from the client to the resolver through a series of devices and wires, such as routers. So anybody who is sitting in the middle, man in the middle, they can see what you are doing, what websites are you surfing. So there is no privacy basically. So what can we do is, if somehow we can encrypt whatever query we are giving or whatever response we are getting, somehow we can, if we could encrypt, then the man in the middle, it will only get some encrypted text for which it cannot make sense that what it is. Now this encryption that can be done using two technology. One is DNS over HTTPS. So HTTPS, you may be knowing that this is a web server technology, so through which we basically access websites. So here also we will set up a web server through which I can send my query and I will get the response. So this is another protocol, DoH. And next one is DNS over TLS, where we will encrypt the DNS query and response using TLS protocol. So DNS over TLS is basically.
Sorry to interrupt you, Anoop-ji. There is a question from Surya Khan. Is there any kind of configuration has to do?
Any kind of?
Is there any kind of configuration has to do for each security option?
For each security, I did not get, sorry.
1 minute, I'm just sharing on your chat. Yes. In the chat box, there is a question.
Okay, no. We have to do the configuration. We'll go at the last, that implementation part.
Okay.
Okay, so we'll see. So DNS over TLS, basically it is in encryption on top of the UDP protocol, and it safeguards from the man in the middle. So they won't be able to know what websites are we surfing. And it runs on default port 853. We can also change the port. There's no issue in that. And nowadays it is supported from Android 9 plus, iOS 14 plus, and some packages are there which can enable in Windows and Linux also. DNS over HTTPS is basically the DNS queries are sent over HTTPS, and a web server will be there which will interact in the backend with the DNS resolver and give you the response again as a HTTPS response. So this works on port 443, the default port. And in this part, so in DoT also, we directly contact the authoritative name server, which will give me the response. Well, it will be encrypted, but I get the response directly from the authoritative name server. But in case of DoH, we are basically, the client is basically talking to a web server, and the web server is acting as an intermediary, and that in turn will talk to the DNS resolver and give us the response. So there are several DoH server already established. For example, we have also established one DoH.iref.in. There is Google DNS, dns.google, and cloudflare-dns.com. So these are some of the DNS server which you can use in Firefox, for example. So how does it work? So there is DNS or DoT server, and we send it we ask for the IP. In the backend, it will connect to the, again, same thing, root server, then the next .in server, and finally the authoritative server for C-DAC.in, and final, the whatever response it is getting from the C-DAC.in name server, it will return to the client. So remember, the communication from the client to DoT and DoH, only this part is the encrypted part. But after that, whatever is going in the backend from the DoT or DoH server to these servers, they are not encrypted. Okay, so only from the client to the DoT or DoH server, that's the encrypted part. So so one thing is, which one can we use, DoH or DoT? Well, it is up to individual. We can use anything. But there are some questions. For example, is DoH really secure? Well, no. So basically, whenever you make a encrypted query through DNS using DOS, yes, whatever your query and response are encrypted. But after that, you have to surf the website. So for that, you will connect to the web server, and as soon as you connect, people will know what you are connecting to if somebody is there. And even if you use HTTPS, there is one SNI, server name indication, which will give the name of the actual server that you are connecting to. So in that way, maybe DNS part is encrypted, but whenever you are connecting to the directly to the web server after getting the IP address, then any man in the middle can know what website you are connecting to. If you want absolute privacy, then you can use Tor in conjunction with DOH, or you can use VPN. So that will be absolute privacy, not only the encryption of the DNS, but also of the other things. Now DOH versus DOT. So we versus DNSSEC. So DNSSEC, we have already known that DNSSEC is only for the authenticity of the record and integrity of the record. So whatever response I am getting, that is authentic. It has not been altered. It has not been changed. But what about DOH and DOT? So it is for the confidentiality part. So my records, whatever response is there, that is encrypted on the channel. So it is only for channel security. So if we can use both, and we will get a complete authenticity, integrity, and confidentiality. So this is all from the presentation point of view. Now we will see the implementation. Before that, any question is there apart from the implementation question, conceptually and for conceptually understanding it? Okay, no, then I will just unshare and I will connect to my terminal. Configuration of DOH and DOT servers are different from normal DNS configuration. There's one question. It's different, but we can do on the same server. So for example, if I use bind for the configuring our DNS server, in that DNS server itself, I will add 2-3 more parameters, and my DOH and DOT will be enabled. We'll see this. I will configure from the very basic. Any more question before we move to the implementation? Okay, so I think no. Then we'll move on to implementation part. So I'll share my terminal. I will stop this and share my terminal. Okay, so this is my terminal, and I am basically using a virtual machine of Ubuntu server. So let me show you lsp_release-a, which will give me the information about the Ubuntu server. And you can see it is Ubuntu 22. Next, I will show you the host name. So host name is doh.pkindia.in. And this is already pointing to my own local host server. Next is my IP address. So I will show you my IP address. So my IP address is this 172.16.11.128. So this is my IP address. So these three are just for the information. Now next part is I will show that currently I'm not running any DNS resolver. So for example, nslookup C-DAC.in, and I will enter my own IP 172.16.11.128, and you will see that connection is refused. So basically there is no server running, so that's why the connection is refused. So next, again I will clear it, and I will install bind. So I will be using bind for the demonstration. Now, in the earlier session, there were so many dependencies, but for Ubuntu, all I have to do is apt install bind 9. So this is the command, apt install bind 9. And installation is done. That's all. So just one command, apt install bind 9, and the bind 9 is installed. Now, to check whether the my server is working or not, I will run again the same NS lookup that I did earlier. Earlier, there was no response. Now you can see that there is a response. So it means my local DNS server has started running. Now, after this, since we will be using DNSSEC, so there are two parts. One is that whatever authoritative name server is there, they should implement DNSSEC. Second thing is the client that I am using, means basically my computer, my browser, whatever client is there, they should also be able to verify the DNSSEC. So let us, I will show you, I will check whether my client is DNSSEC enabled or not. So for that, 172.16.11.128. So I am basically dig is one tool. I think last session it would have been shown that dig is a tool using which also I can get the response from my DNS server. So I will show for nixie.in itself. So dig @ my local IP nixie.in plus DNSSEC. So this is basically a flag which I am using to tell dig that give me the DNSSEC record, and plus multi. So multi is just for multi-line support. Now if I put this command, you can see that for nixie.in, it is giving me RRSIG, which I was calling the resource record signature. So since it is giving me RRSIG, it means that nixie.in is DNSSEC enabled. Another thing is here in the response, you can see there is one thing called AD in the flags. AD is for authenticated data. It means it has also verified the signature on that resource record up to the root level. Not only up to the nixie.in, but up to the root level. So in that way, these two things, that RRSIG is already there and AD is already there, it means that my client, dig client, is enabled to make DNSSEC query. Now, next. So next part is I will create a zone. So for creating a zone, we have to go to etc bind. So this is the binds directory. So here there are multiple files. One file is named.conf.local, in which I can create a local zone. So if I have to create a new zone, I will go to this and create the local zone. Then named.conf.options. So options are basically, for example, do you want DNSSEC validation? Do you want to listen on a particular port? And what is the working directory of bind? So all those things will be covered in the options. So let me show you cat named.conf.local. So local, it will be blank because there is no zone. So if I have to add a local zone, then only this will be used. Next, I will show you options. So options, there are multiple options. So for example, here you can see the directory is where cache bind. It means that anything I want to put, suppose my zone file I want to put, or any key file I want to put. So all those things I will put it in where cache bind, so that the DNS server will have readily access to that resources. Then we have DNSSEC validation auto. I was just talking about this, that my client should also be able to validate the DNSSEC and listen on IP basis. So that's all currently. We will add more options later when we go to DoH implementation. So now we have to add a zone. So for adding a zone, nano named named.conf.local. So this is basically where I can create my zone. So I will just go here, and in this I will add a zone. So zone anoop.cdac. So I'm just adding a non-existent domain. In is for internet class. Now this zone, it is of that. So first we have to declare the type of the zone. So it is master. Now DNS server, whenever you create an authoritative DNS server, you can have multiple authoritative DNS server in which one can be master and another will be slave. Why this architecture? Because if you have a master server, so automatically the slave server will sync from the master. So any change you need to make only in the master server, the slave servers will automatically sync. So this is one benefit. Second thing is, even if the main primary server is down, the users can get the values from the secondary name server. So that's why people keep multiple name servers in which one they can declare as the master. So here this is my own only zone. So I will create this itself as the master, and then the zone file. So where all the entries will be there, like www.cdac.in or www.mail.cdac.in. So these entries, all these are in a file. So let me give a name to this file, Anoop, or maybe CDAC. Done. So only these two things are there: zone, the name of the zone, in for internet class, and then type master, and the zone file CDAC. I will save it, Control S, Control X for exit. Done. So my configuration is done. Now I will have to create a zone file. Now, how do I create a zone file? So I can create a zone file from scratch, or if you come, I will just do a ls. You can see that already there are some zone files. So I will just make a replica of that zone file and then edit that zone file. So I will copy it, db.local, and copy it to my var cache bind directory. Why? Because that is my working directory for the bind. And I will give it a name CDAC, because I gave the name for my zone as CDAC. Done. Now I will open this. So nano/var cache bind and CDAC. So here I have to make changes. So instead of localhost, it will be anoop.cdac. Similarly, this is the administrator of this domain. So again, it will be anoop.cdac. Next, I will come here and replace it with @ @ means same server. So my name server is this server only. For this, I will give the IP address, which is 172.16.11.128, and some IPv6 address. I will remove unnecessary things. I will add one more, www in a, and suppose 1.2.3.4. So this is my IP address. I will save it. So this is my zone file. Save it, exit, and two things first we will check. First, so there are two commands. One is named-checkconf, which is for checking the configuration. So there is no error. It means that my configuration is fine. Second one is named-checkzone. And what is the zone that I want to check? So my zone is anoop.cdac. And where is the zone file? So zone file is in var cache bind cdac. So check zone, named check zone, it takes two parameters. One is the name of the zone and another one is the location of the zone file. So you can see that zone loaded serial number 2 and OK. So it means my configuration is also correct and my zone file is also correct. So now I will restart my server. So for restarting, there are two ways. One is I can say systemctl restart bind 9. And second one is instead of bind 9, I can also use named. So named daemon, earlier it was there. So that also I can use. Once I have completed this, I will check using ns lookup. So ns lookup, just now whatever domain I have created. So www.anoop.cdac. And where do I want to query? So 172.16.11.128. So it is returning me the IP address 1.2.3.4. It means my zone configuration is totally fine and totally working. There is no issue in that. So any query till now? Okay, so since no query, then next part is, since we have already talked about this, we have already configured the zone. So let us implement the DNS sec. So for that, again, we will go to our named.conf.local. And here we have to do two things. So first thing is we have to specify the DNSSEC-Policy. So consider that the name of the DNSSEC-Policy is DP, just some random name. And second thing is I have to enable the signing, automatic signing, which will be inline signing, yes. So these two things implement, these two lines that are the only lines that we need to add for the DNSSEC signing. But we have written here the policy, DNSSEC policy DP, but we have not defined what is this DNSSEC policy. So let us define this DNSSEC policy. So DNSSEC-policy space DP. Whatever name I have kept here, same name should appear here also. So I'm defining this policy. So first thing is I will give the zone TTL. So max-zone-ttl, which will be 604800. So TTL set. Next part is keys, because you already know that there are two kind of keys that we need to define. Now, any this keys, which public key, private key, there are multiple things with the keys. One thing is that which algorithm should be used for generating the key. For example, there are RSA, there are ECDSA, which is for elliptical curve. So which algorithm should I use? So that we have to define. And second thing is that these keys, they are not for lifetime. They are not for always. So we also have to specify that for which period they will be valid. And last but not the least is NSEC3 parameter. So three things. One is max-zone-ttl, second one is keys, and third one is NSEC3 parameter. Now, coming to the keys. Now there are two keys, KSK and ZSK. So KSK, I will define the lifetime. So we just have to write by one space. So we just have to give one space and then next. So KSK, lifetime is unlimited for the KSK, and then algorithm. So algorithm ECDSA 256. So this is for the key signing key, and similarly zone signing key, lifetime. Lifetime, this time I will define for 60 days. So capital P 60D, it is basically the ISO format for defining a date, time, or a period. So capital P is for period and 60 days. And algorithm ECDSA 256. So we'll save it. So this is our DNSSEC policy. So in this policy, I have taken care of three things. One is the zone TTL, another one is the keys, and keys contain two things. One is key signing key, another one is zone signing key. And then I also have asked it to use NSEC3. Then in the zone file, I have given the which policy I will be using. So DNSSEC-Policy DP and inline signing, yes. So it will start automatic signing of the domain. So we'll save it, go out, and first thing, named-checkconf, whether my configuration file is correct or not. So there is no error. Then I will restart. So ctl restart named. Done. Now I will check whether DNSSEC is enabled or not. So for that, again, dig @172.16.11.128. And what is my server? So www.anoop.cdac. So for this domain name, I am querying, and plus DNSSEC plus multi-line. So now you can see that for www.anoop.cdac, it has returned a resource record signature. So it means that this zone is DNSSEC enabled. So I'm getting a RR signature. But what about the flag AD? So AD is not there. Why? Because for AD, I need to have a actual domain, and I have to put my DS record in my parent, which I have not done yet. So for DS record, just 1 minute. So for DS record, let me clear this up to here. We have already seen. So dig @172.16.11.128. Now DNS, 1 minute. So DNS, I am opting for DNS key for this domain anoop.cdac pipe dnssec-ds from key -f anoop.cdac. So this is the command using which first I'm obtaining the DNS key, and from that DNS key I'm creating the DS record using the command dnssec-ds-from-key. So this gives me the DS record. So this DS record, I have to give it to my parent zone. For example, in my case, C-DAC.CDAC will be my parent zone. So .cdac I will give it for publishing this DS record in their zone file. So this was DNSSEC implementation. Too easy. We just have to define the DNSSEC policy. And once we have defined the DNSSEC policy in the zone file, we have to give we have to define this DNSSEC policy. And once this policy is done, we just have to tell the zone file to take that DNSSEC policy and start signing the records. Now, earlier what used to happen is that whatever signed records were there, they used to be written in the same zone file. But with inline signing, your zone files remains unchanged. So for example, cat where cache bind C-DAC. So this is my zone file. You can see this is same as the unsigned zone. But when I am putting a dig, the server is signing on the go and then providing the response. So this is all about DNSSEC implementation. Okay, so one question is there, no configuration is needed for the host file, no. So for the zone file, we do not need anything. Just in the configuration in the where we are declaring the zone, there only we have to define the DNSSEC policy and start the inline signing. We do not need to make any change in the this DNSSEC. So earlier the process was very cumbersome. So where you have to generate key pair, you have to sign it, and then you have to append it in the zone file. So that was a cumbersome process. But with latest this bind version, we don't have to do anything. All the signing is automatic. You just define the policy. So this is done. Then we'll move on to DoH and DoT. Now, since DoH and DoT, it works using TLS protocol because ultimately HTTPS is also HTTP plus TLS. So we need a public key and private key. Now, since just like for any web server or website, for example, nixie.in, there will be one TLS certificate and a private key. Similarly, here also we require a public key and basically a certificate and a private key. Now, you can get it from anywhere. For example, nowadays, Let's Encrypt is giving that for free. Or you can also buy it from anything. For example, you can buy from eMudra or whatever online provider are there. Like for example, zerossl.com is there, or in fact, ssl.com itself is there. So many are there. You just have to buy from any one of them, or if you want free, just use a Let's Encrypt. So for my case, for this example, I have already got one private key and one public key, public certificate. So let me use them itself. So I will copy them to my where cache bind, because that is my working directory. So basically I am copying that to my this working directory. So in the document folder, my keys are there. So now we can ls/where cache bind. So here you can see that there are two files. One is fullchain.pem, which is basically the certificate file, and another one is private.pem, which is for the private key. One additional step, I will change the ownership of these two files. So change owner bind:bind /where cache bind *pem. Since bind will be accessing these files, so I have changed the ownership to bind. Next. Okay, so next is we will open the options file. So nano named.conf.options. So options, there are so many things. Let me delete these comments. Whatever double slash is there, it is comment. So I will remove it. And first, I have to define that where my certificate and private key are there. So TLS, and I will give it a name, suppose DoT. Semicolon. And in this, I will define two things. One is key file, and key file will be private.pem. And second one is cert file, which is full chain dot pem. So these two certificates I have got from Let Us Encrypt. So these two I will declare that for the TLS, the key file is private.pem and the cert file is full chain.pem. Okay, so question is how can you show that how to make these files? Now for making these files, basically you have to go to Let Us Encrypt. Let me stop and I will open my browser and show you. So this is my Chrome browser. You can search for Let Us Encrypt. Go to Let Us Encrypt. Get started. And go to this cert bot. So certificate bot, which will basically create a certificate for you, and then click here. And here, depending on what software you are using and what operating system is there, for example, Ubuntu 20, it will give you the instructions. So just follow those instructions and you can create the certificate. So another way is you can use OpenSSL on your own system, but that will be a self-signed. So self-signed is not valid. Okay, so that's why we do not use a self-signed SSL certificate, but for practice purpose, you can always use that self-signed certificate. But for production server, you should go to this Let Us Encrypt certbot, and depending on what software you're using and what operating system you are using, it will give you the instructions, run that command and get the certificate. Okay, back to our terminal. So once I have defined the this TLS DoT, so first thing I will do is listen on port 443. So I'm defining that for DOS, you listen on this port 443, and then for TLS, you use DOH. So DOT, whatever I have defined here. So just like you remember this DNSSEC-Policy I had defined, given it some name. So same here also, I have defined TLS and given it a name DOT. And then HTTP default. So what is HTTP? So HTTP is basically the endpoint. So for example, www.cdac.in/DNS query. So /DNS query is the endpoint of the API where I will connect and get the response for my DNS query. So all the APIs, they have an endpoint. So here the default endpoint is /DNS-query. So, but we can change that also. So we'll see that. So so this is done. And next, listen on port 853, because I also have to configure DoT, TLS, DoT, and this time that's all, because for TLS we do not require any HTTP. So simply any. So we have to define the key file and the certificate file where they are, and then we have to listen on those ports 443 and 853. Okay, so once you are done with these three, these are the only lines that you have to enable. That's all. So Control S and Control X, and then we will restart. We'll restart the named. So once you have restarted, now we have to check whether my my this DOH and DOT is working or not. So for that, there are multiple ways. For example, dig @172.16.11.128, and then my what query I am putting. So www.anoop.cdac plus, so here I can put HTTPS and plus multi-line, or I can remove multi-line. It's okay. So plus HTTPS flag says that you have to query the DOH server, not the usual name server. So you can see that it has given me the response in the answer section. And here also you can see the server. Can you see here? The server is HTTPS and connection is made on the 443. So it means that my DOH is working. Same way, let me clear it first. So same way, instead of HTTPS, I will make it TLS. So plus TLS. And then you can see that answer is there. And also you can see here the server is TLS server, and port also you can see that it is the 853 port. So it means both my DOT and DOS server are running perfectly fine. Now there are other ways also for checking it. So one of them is like curl. So curl -DOH URL. DOH URL, and then I have to give the DOH URL, which is HTTPS and DOH.pkindia.in/DNS-query, and then what website I want to access. So HTTPS and then suppose google.com. So in the curl command, basically I am asking the DOH server to give me the URL of google.com, and once the IP is obtained, IP of the google.com, and once the IP is obtained, the website will be served using the curl. So I'll press enter, and you can see that the website is returned. It means my resolution was successful. Suppose that I change this endpoint, DNS query. If I remove this, now this endpoint will not match. It means my DOH cannot be reached. So in that case, if I press enter, you can see could not resolve the host name. Why? Because my URL is incorrect. So the question is, can I change this URL? So yes, I can change. So we'll go back to named.conf.options, and here for HTTP, we will define another thing, which is DOH. So this is just a name. DOH is just a name. You can give your own name also. There's no issue with that. And here I will put endpoints. And in this, I will say, for example, my endpoint is only / no /DNS-query. And then I will close it. And here, instead of default, let me comment it and copy it. So first line I will comment, and in the second line after HTTP, now I don't want the default part. What I want is my own DOH. So I have changed the endpoint. By default, it is /DNS-query, but now it will be only /. So save it, exit, restart. And then curl. So the same curl, now it's removed DNS-query and run it. And you can see that this time it is not saying that could not resolve. Same thing with dig. So dig, if I go to dig plus HTTPS, Now, by default, when I put plus HTTPS, so it gives me from /DNS query. But since I have changed it, so I will have to tell what is the new endpoint. So I write it by plus HTTPS equal to /. And then let me add one more thing, DNSSEC. Anyway, we have also enabled DNSSEC. So let us see both, that how can I get DNSSEC response from the HTTPS server. So press enter, and you can see that I have got the RRSIG, and also I have got the response from the HTTPS. Okay, so that's all from my side in the implementation part. Any query is most welcome. I think one of the query was that how can we do the reverse zone? So basically it's the same thing. You have to create a declare a zone, the reverse zone in, and then type master and file name some file. Now if you see, just like db.local was for forward zone, db.255, this is for the reverse zone. So you can copy this db.255 for the reverse zone. Let me show you the content of this cat db.255. Okay, so in that way, using this, you can also do the reverse. You can see here it says bind reverse data file for broadcast zone. It is for 255. There is this is for 127 local also. So you can see here at the bottom, you can see the PTR record. So same way, you can also create your own zone. Now, practically, if we see, when we get some IP address from a service provider, say like BSNL or PGCIL, then they maintain the PTR record. So whenever you create a zone on their IP address, you can ask them to create a corresponding PTR record if you are hosting yourself. So one question is, do I need to install Apache? No. So whenever you are using DoH, so by default, the latest bind from 9.18 onward, they have included a small web server in the bind itself. So separate Apache or separate Nginx do not need to be run. You have seen here now itself. I have not installed anything extra. I have just installed the bind. Okay, so configuration file for the DoH, I will again show. So nano named.conf.options. So in that, first one is this TLS DoT, where I am defining the key file and the certificate file, because any website, for TLS, it requires a private key and a certificate file. So that I have defined. And second one is basically for defining the endpoint. If you want the default endpoint, you can always use this line, HTTP and default. But if you want your own endpoint, then you have to use your own endpoint, like I have defined here /. Now there are only two configurations. One is listen on port 443. Then I am saying that for TLS, you use this certificate. What certificate? Which is defined on DoT. 1 minute. So which is defined on DoT. And for HTTP, I am asking to use the endpoint which is defined in DoH. For DoT, which is for TLS, I do not need any HTTP part, so I will end it here itself. TLS DoT, that's all. So question is, Other than these, any other security option exists, or these are enough for production server? Well, there are multiple things. Fine. So for example, when you are creating master and slave, so you have to define who can take the update, and then will those update also be signed? So there are transaction signatures also. Then there are other considerations in DNS. When we will go through the attack in the last session, then you will see that there are multiple attacks. For one of the example is reflection attack. Currently, rarely there are any secure solution for that. Then there are DNS tunneling attack. There are some research solutions, but they are limited to research. So these are not enough for all the attacks, but they are enough for authentication, integrity, and the confidentiality part. That's all. Any more questions? So one question is, what is the use of AXFR? So that is for the zone transfer part. I have not covered that. My goal was only to cover the DNSSEC, DoH DoT. So, but as I explained earlier, that we have multiple zone servers because we want availability, so that even if one zone is down, another zone can take over. And in that case, we create one as the master, others as the slave. We make change in the master, and we only allow those slaves to take the change after a certain duration. So in that way, all my zone will remain updated. Now, practically there are, like here we are showing you the implementation on bind, but there are multiple dedicated appliance. For example, we have one dedicated appliance from F5, which is only for DNS and DNS security. So it implements everything in that box itself from the security part. In fact, they have a firewall also, and they also have some sort of denial of service attack, but that may not be sufficient. Any more questions? Okay, so then that's the conclusion of my session. Thank you all. So one question is, in case master goes down, slave servers will work? Yes, they work for certain period. So you have to define for how long they will work. After that, their data will be invalidated. So the master has to come up. So you would have seen that SOA record. So in the SOA record, basically in the SOA record, you can have defined that at what after what duration the slave has to recheck. Okay, then that's all. Thank you all.